Hello, so we are presenting on the membrane application in fermentative production of lactic acid, and this will be done by Felista and planes. So looking at the fermentation route for the production of lactic acid, we can see its contribution to around 90% of the commercial lactic acid. And here the membrane technology has found its application due to its high efficiency and improvement in the product yield and the product quality. So specifically in this route for the production of lactic acid, the membrane is applied in the pretreatment and the purification stage. So looking at the feedstock, which is the sugarcane bagasse, secondary generation feedstock that is cheap and produced widely, around 0.3 tons for every ton of sugarcane. So looking at its composition, we can see more than 60% of it is carbohydrate, that giving it a value to be used for the production of lactic acid. And for the fermentation process, we know the microorganisms are the one playing a huge role. As the lactic acid producing bacteria, specifically the Lactobacillus casei, has found application due to its ability to utilize both hexose sugar and pentose sugars that are released during enzymatic hydrolysis and other attractive features. So for the process description, that is mainly divided into two, the upstream and the downstream. Looking at the upstream process, we mainly have the pretreatment that is done by the size reduction of the feedstock, followed by the chemical pretreatment, here using the sodium hypochlorite and acetic acid under this condition to remove the lignin, and has shown high efficiency to remove around 85% of the lignin and high recovery around 98% of glucan. So after this stage, the solid residue that is rich in cellulose and hemicellulose is now sent for the enzymatic hydrolysis. This occurs in a membrane bioreactor where we have the enzymatic hydrolysis using the commercial enzyme, which is celic CTEC, that is comprised of cellulase and hemicellulose, degrading cellulose and hemicellulose respectively, followed by the filtration using the ultrafiltration that has a molecular cutoff of 10 kilodalton, is able to reject around 98% of the enzyme and micromolecules and permeate glucose with a yield of 98%. So after this, the retained are circled back to the reactor for the further reaction, while the permeate with more of the simple sugars are sent for the fermentation. So here we have the L-casei microorganisms that have ability to metabolize glucose to lactic acid using the lactate dehydrogenase enzyme, and the lactic acid produced now is sent to the downstream for the separation and the purification.
Okay, so in the downstream process usually require combinations of processing units, and this development we propose the integrated separation method involving ultrafiltration, which uses a 30 kDa membrane to be able to retain the microbes and as well as macromolecules and recycle them back to the fermentation reactor while permeating lactic acid, glucose, and then salt, which further goes to nanofiltration. In the nanofiltration, the target is to be able to retain glucose and divalent salt, and the separation is based on two mechanisms. The first being separation by size. The nanofiltration membrane have a molecular cutoff between 100 to 150, and glucose having a molecular weight of 180 means that to be able to retain. And the nanofiltration is also a charged membrane. Here we use polyamide membrane, and at low pH, the membrane is positively charged, and hence be able to repulse the positive divalent salt while permeating lactic acid, which is non-ionized, together with monovalent salt, which further undergo ion exchange. In the ion exchange, we use selectively resins to be able to remove the monovalent salt while permeating dilute lactic acid, which is further concentrated using a vacuum-assisted evaporation. At 80 degrees, it's able to concentrate the lactic acid to about 76% by weight. An additional step is crystallization, which helps in the production of solid lactic acid. In terms of applications, lactic acid found application in various industries, including the food industry and in the bio-based chemicals. And for instance, the lactic acid L+ monomer is usually used in the pharmaceuticals and food industry, while the combination of the L+ and D- isomers are used in the chemical industry. So conclusion, we found that lactic acid production through fermentation process is eco-friendly and sustainable, and there have been a rising increase in the use of membrane technology in the production of lactic acid. Future development, there are more research work on developing engineered strains for lactic acid production, and there have been a rising increase in the production of lactic acid. Thank you, and here are references.